How you going, guys? Curtis from Cutting Edge Engineering. So today's job, we have 4 pins we need to remake. We have 2 pins out of a D9T bulldozer. These pins attach the ripper frame onto the chassis of the machine. As you can see on the ripper pin, there is a lot of wear in the center. That is the main pivot point when this is attached onto the machine. When it is ripping, there is a lot of forces applied to the front and the back side of the pins, which then causes them to wear. And these 2 bigger pins, they are off a Hitachi ZX670, which is a 70-ton excavator, and these pins attach the bucket onto the machine. As you can see, one of the pins has a lot more wear than the other. It is pretty much a camshaft. That is a direct link from the bucket to the dipper arm of the machine. This pin has to support all of the digging forces and the loading of the bucket. Whereas this pin, that doesn't suffer as much punishment because it connects the H-link from the bucket to the cylinder and it controls the pitch and the crowding of the bucket. So we're going to get started on the 2 bigger pins. Even though they are bigger, there is less work in them. Where the smaller pins, it's going to be machining, drilling, threading and welding for those. The first thing we're going to do, we're going to get the big one set up in the lathe and we're going to machine the head plate off the pin. There's actually nothing really wrong with those, so there's no point to replace them. We'll save the customer a little bit of money, take those off and reuse them on the new pins. Righto, so I've got that set up, so I could go and use a standard tool holder like a W&MG. I do have enough clearance in order to use that, but because that's a welded area, it is going to be an interrupted cut. I'm more likely going to break inserts, so I'm just going to use the tried and tested method, which is going to be my button tool to hog out that weld so we can remove the head plate. Righto, so we've found the joint in between our pin plate and our pin. I'm not going to machine that any further because there is a possibility that plate could come off, and if it spins around it could break a tool or do some damage to something. I'll get this piece of material out of the lathe. I'm going to bring over the new piece and set it up because this pin is 130mm in diameter and the other pin is 120. So while the steady is already set up for doing 130mm material, I'm going to machine up my new pin and then I can change the setup for the next pin. So the material we're going to be using to replace our pins is induction hardened 38mm VS6 chrome bar. It is the same material that we use for our cylinder rods, and it's basically the same material the original pins are made from. So I'm not going to be putting tape on the face of the steady. Where I'm running the steady, there are no bushes or seals that will be running there, so if it was to get damaged, it's not going to affect the operation of the pin. All we need to do with this end is face it and chamfer the end of the pin, and then we can flip it. So that ceramic insert just kept breaking tips and then it finally broke in half. They are a pretty finicky insert. You might end up finding one that will just keep on going, and then you will find one that just doesn't last at all. So I'm going to run this ceramic insert. It is very damaged. There is a side missing out of it, but it will probably complete the job. So that is the induction hardened layer removed, and that broken insert survived the rest of that job. Now we're going to change out the insert for a carbide, and we're going to machine down this end to suit our pin plate. So that's the machining on the first pin done. Pretty simple, pretty easy. What I'm going to do now, I'm going to take this one out of the machine, get the other pin set up and get it up to the exact same stage. So there's not as much involved in machining these pins. We don't have to drill any holes through the pin in order to get grease to the bushes. Grease is fed in through the dipper arm and through the H-link into the bushes. So that's all the machining done on our big pins. All we need to do now is weld on the plates, but we're not going to do that just yet. We're going to get our D9 ripper pins up to the same stage so we can weld them all together. So let's get stuck into that. So we're going to start machining up the new ripper bed pins. The material we're going to be using is 3.5-inch induction hardened chrome bar. I'm going to face and chamfer the bottom end of the pin. I'll then flip it. I'm going to turn down a little bit of the induction layer just so I can put a nice weld around the pin. I then need to drill and tap down the inside because grease passes through these pins in order to grease the bushes. Righto guys, now that we've got that done, what I need to do now is drill the hole in the end of the pin for the grease. That hole is 8.5mm in diameter, but it's 210mm deep. So the first thing I'm going to do, I'm going to put a center in the end of the pin. I'm then going to use a standard length 8.5mm drill, which is going to be our pilot, and then I can come in with our 400mm parabolic drill to drill the pin to depth. So I'm going to be using a parabolic drill because of the depth I have to go to. I don't want swarf to get trapped. Parabolic drills have a much wider channel in them to allow swarf to escape, and it doesn't bind up as much around the drill. So this is going to be the longest part of the job because you do need to take your time. You sort of just got to go in and just keep pulling material out very slowly because you do not want to break one of these drills off in the pin. If you do, you throw the pin in the bin. Righto, so that went to plan. We've got that hole to depth. What I need to do now is drill a 29.5 diameter hole, 70mm deep. Then I'm going to counterbore down with a 35mm drill just to relieve the top side of that hole, and then we're going to thread it. The reason I have to counterbore it is there is an O-ring seal that fits over the fitting that gets screwed into the end of the pin. Righto, so that's the lathe work done for this pin. We're going to get the other one up to the exact same stage, then we'll take them over to the mill. So that's all the lathe work done on the 2 pins. Going to take them over the mill, set them up so we can drill our holes. So we're going to set the pins up on our shop-made V-blocks. These might look familiar. We did make these in a previous video, but I did decide to clean up all the faces and send them out for nitriding. So I found center of the pin. I'm going to use a 12mm ball-nosed carbide end mill to get through the induction layer. Then I'll put a standard twist drill in. Then I can drill down and meet up with the hole I drilled through the pin on the lathe. Now that we've finished all the machining on the pins, we're going to take them over to our welding area and weld all the plates onto the pins.
Uh-oh.
So the wire we're going to be using to weld the plates back onto the pins is ER70S6, it is 0.9 or 035. The gas we're going to be using is Argo Shield Metal Core, which is a 90-10 gas mix. Righto guys, so all the welding is completed. I've let them cool down. So a job like this is pretty quick and easy. We are getting them on a weekly basis. We make pins in a range of sizes, from an inch in diameter for farming equipment like tractors, all the way out to a 250 ton excavator. And those pins are up to 200 mil in diameter. We're going to get them strapped down to the pallet, get them back to our customer so they can reinstall them on the machine. Thanks for watching. How'd you start it? How'd you start that? How'd you start it? How do I start that? Where am I starting from? Gotta get the laugh out. I got it. You ready?
Yeah, okay, here we go.
Right, so, fuck. So I'm not gonna be putting
Do you know what you're saying?
something about the pins. And drill through the pin into the hole I drilled down the center of the pin to allow the grease to pass through the pin. That's lots of pins.
That was too much.
The drill was actually 200 mil longer than it is now when I first bought it. Fuck off, train. Fuck off, train.
Is that all grease or is rust or what's
Rust,
that?
Grease and dirt.
Ew. So that'll be scrap.
That'll be scrap. Well, I could regrind it into a crankshaft. Oh my goodness.
Did you get it?
Ever heard this thing full swing?
No.
Just spin a fucking big motor.
Send it. Cat bolts.
Where's my fucking square gone?
This square. Damn it. Whoa. Yep. Oh dear. What's down there? What's that? Look, look. Over there. Down there. Go get it. Come on.